Hello and welcome to the Exploration Command Center at Florida Atlantic University's Harbor Branch Oceanographic. Nice to have you here today. I'm Scott France and this is Brian Kennedy, and we are standing in the ROV control room on board the NOAA ship Okeanos Explorer. We're about 200 miles southeast of Cape Cod, beginning to dive with the ROV to a depth of 2.5 kilometers.
So what you're seeing right now is the control room on America's ship for ocean exploration. This is really the nerve center of the vessel. Right now the ROVs are in the water descending on Physalia Seamount. The screens behind me you're looking at right now are the ROV pilots and what they're watching. That colorful card you're seeing right now is actually them calibrating our cameras to true color. We'll be descending onto Physalia. We'll be down to the bottom about an hour, exploring this seamount for the first time ever with a remotely operated vehicle. This vessel is unique in several ways. It's the only ship dedicated to systematic ocean exploration for the United States. And we also use something called Telepresence, is what you're experiencing right now. And I'll turn it back over to Scott a little to talk about that and how we use the exploration command centers like the one you're standing in.
So the ROV is a remotely operated vehicle. It's essentially a robot of sorts, and it's being controlled by pilots and navigators here in this control room. We're sitting on the deck of a ship, and the ROV is descending below us to the sea floor. It has high-definition cameras on it that are able to transmit these just glorious images of the organisms that live on the bottom, the geology of the bottom, transmits them up the ship, and then the ship has a satellite that can beam them to shore, and then it goes out to the exploration command centers, the ECCs, like the one that you're in right now. We also have a group of scientists who are located in institutions in ECCs like you're standing in, and also other institutions, other ECCs around the country. We can even have scientists from around the world that are collaborating through an instant messaging system, something we call the event log. And so the scientists like myself and Susan Schnorr, our geologist on this leg of the cruise, have our laptop computers and are constantly monitoring and having an exchange with the scientists on shore, making observations of what we're seeing in real time out here on the ocean. And in this way, we can collaboratively better understand what we're seeing. We can have guidance from the scientists on shore who may be interested in certain features that other scientists may not be. It's really good input, and make sure that we don't miss anything, that we can use the capabilities of the ROV and the vessel to its maximum. And so this telepresence concept is really exciting to engage a lot of people that you couldn't all bring on a ship at one time. Get a lot of expertise in that way. Over the last couple of weeks, we've been on the third leg of this expedition that started in early August. We've been exploring canyons of the eastern seaboard. It's really interesting that we're just at some points maybe 60 to 70 miles off some very densely populated shorelines. New York City, for example, we're investigating canyons, huge canyons. We're not talking about small features, but canyons on the scope of the Grand Canyon that are undersea that have never been explored before. And so it's really fascinating to think of these features, these undersea features that are so close to a lot of people, but we don't have any understanding of them. And so these are the first explorations of these features. We've also been exploring seamounts. These are basically undersea volcanoes that extend off the shore, looking at the potential resources that are there, fisheries of economic importance, and how they interact with the bottom features. There are deep sea corals in these areas that provide habitat structure. How do the organisms interact with those corals? We're also interested in looking for chemosynthetic communities, things like cold seeps, where there are sources of methane and organisms that may be taking advantage of that environment. So lots to explore, lots to learn, and lots of scientists that can be involved due to this telepresence concept.
So one of the things that I find most exciting about this way to explore is that so many other scientists are able to participate in the expedition. So it's a really unique paradigm, if you will, for exploring our world's oceans. And for example, yesterday, I was really excited to participate because I was able, without having to be out on the ship, and to be able to see some new communities, and I work on sponges, some new sponges that I had never seen before. I was especially excited about the carnivorous sponges and those are relatively new to science, just really over the last, I guess, a decade or a couple decades or so. So it's really exciting to see so many of them, and I'm not sure, how well they've been documented in the North Atlantic. Probably not very well, if at all. So I was really excited to see that, and that's one of the major advantages is that, normally when we go out to sea, because there are limited spaces, you can only take a few experts. And this way we explore now that NOAA has made available to us through the Okeanos Explorer and Telepresence really allows many, dozens of experts. So, Scott, you can ask, a crustacean expert or a sea star expert for feedback, and that's what you're getting through this instant messaging and the event log and the chat room. So it's a really exciting way to engage a lot of other professionals. And you might want to talk a little bit about how we can engage non-professionals, so the lay public, students. Can you talk a little bit about how many other viewers, how many other participants are actually participating in these expeditions?
Yeah, Shirley, absolutely, and you're totally right. The ability of telepresence to extend the knowledge base or brain trust of the vessel throughout the entire world, honestly, is really a powerful thing. If we see something we didn't expect to see, we can, in a matter of just a few minutes, change over the science complement on the vessel virtually. We had a great example of that when Stephanie Farrington from Harbor Branch was on the vessel in April. They were diving on what they expected to be a shipwreck, and we had numerous marine archaeologists involved expecting to see a shipwreck. And when they landed on it and found it to be a geological feature, within about 10 minutes, the archaeologists had taken a step back, and the geologists had all called into the conference call, logged in the event log, and they were able to rapidly identify the feature they had seen as something that had only ever been seen one other time. So that's really the scientific power of telepresence is huge, to be able to draw on that knowledge base and find people who are, subject matter experts but don't have to be on the vessel and don't have to spend all of their time transiting or riding on the vessel for only one or two dives of interest. But as you said quite correctly, we can also use that same technology for education outreach. Everything we do, including this conversation, is being streamed live to the internet, so people can hear and learn and follow along what we're doing in real time. And as well as that, the Ocean Exploration Program, in cooperation with SEART, has done numerous education outlets. We have lesson plans. We have expedition education modules for every major expedition we do, like the SEART, Pulley Ridge projects. So we reach a lot of different people. I believe last year we had over 11 million visitors to the Ocean Explorer website. For Okeanos Explorer specifically, we've had over 100,000 views to a single dive last summer, and usually see over 1 million views over the course of a single expedition. Scott, you want to add a little more about that?
Sure. I can also give you a very anecdote that's very appropriate to where you are. I had an email last week from a science teacher at Port St. Joe High School in Florida, who's teaching marine science classes and was using the opportunity to stream the video that we were capturing live. And he says his students were just absolutely captivated, really enjoyed watching it, and so they streamed it a couple of times. And so I'm able to actually in real time say hello to them, welcome them aboard, and get them really excited about the options that they have in their future for studying marine science. Earlier, you talked about the professional aspect of it, and you touched on this, but I just want to go back to it. Even if everybody, the scientists, wanted to come to sea, there simply isn't enough room in a vessel, and there's not even enough room in this control van. And so having the ability to transmit this these signals, this video feed to ECCs like you're standing in now is just so valuable, because we can have a lot of expertise, and you can just imagine the sort of brain trust that we're bringing to sea to take advantage of the video that we get. And I've had many instances on this cruise where I've had a lot of help from scientists on shore, identifying things and perhaps guiding our eye to things that are really important that I might otherwise miss because my training is in another area.
So it might be, a question might come up, what is the value of ocean exploration, especially when we're dealing with such large issues related to the economy of the United States? Why are we focusing on ocean exploration? What value does that bring to us, to our nation?
Well, I think the immediate answer is how do you manage, conserve, or utilize something you don't know or understand? I think a great comparison is honestly the Lewis and Clark expedition. After Jefferson completed the Louisiana Purchase, they honestly had no idea what they bought. And so they launched the Lewis and Clark expedition to truly gather the baseline data of what the rest of America looked like. And, you know, we have a huge submerged America we know very little about. The United States controls more seafloor inside our exclusive economic zone of any other country. In fact, there's actually more seafloor in the United States than there is land area. And we know so very little about it. This vessel our job is to go out and collect that baseline characterization just so we know what's there. A wonderful example of that is some work that we've just completed over the last couple of years, a large-scale mapping effort to map the entire submarine canyon complex from North Carolina to Canada. These areas are of extreme interest for fishermen, deep sea resource management, the NOAA Sanctuaries program, all different aspects who have state agencies who have a hand in governing geospatial planning for marine environments, whether that be fishing, recreation, or offshore energy, had a stake in understanding, you know, the bathymetry of those areas. But in doing that mapping, we discovered over 570 natural methane seeps along the U.S. East Coast that we had no idea were there. And so without this kind of systematic exploration that goes into an area open-minded, just looking to see what's there, we would have never known that this entire ecosystem existed. And there's so many things we don't know about it now because no one has ever researched it. Are these endangered species there? Are they threatened? Do they need to be conserved? Are these indications of extractable natural gas resources? We really don't know any of those questions. And had this vessel not gone out on a mission of exploration and collecting that baseline data, I have no idea how long it would have been before we understood that we had this resource and this hub of biodiversity all on the U.S. East Coast that we just had no idea about.
So one of the other things that maybe some of the viewers don't realize is that these missions are planned with a lot. There's a lot of planning that goes into it. There's a lot of input from the scientific community, and then you at Ocean Exploration take all of this information, develop your cruise plans, and kind of bringing it back to Florida. Last year there was a very successful mission in the Gulf of Mexico. And in fact, we at Harbor Branch and our Cooperative Institute helped to provide some input for some of the dive sites that we've been exploring with funding from NOAA. And that's in an area of the southeastern Gulf of Mexico, so the southwestern coast of Florida, called Pulley Ridge, which is a protected area. And part of what we wanted the Okeanos Explorer to do was to map some of the areas that we didn't know much about, and also to explore some of those features. And this is a really important area because these are some what are called twilight or mesophotic reefs and deep reef areas that we think might serve as refuges for some of the shallow corals that might be affected by impacts of climate change. So bringing it back to Florida, this was a really important expedition for us as well because it actually supplemented and complemented some of the work that's already been done, but at the same time provided new information in terms of these areas and how to expand those areas for protection for important fishery resources and important coral reef resources as well.
Yeah, absolutely. So ocean exploration, the Ocean Exploration Program takes a very collaborative approach to planning. There are so many numerous stakeholders involved in deep sea planning and science that need to be involved, and we do an extensive, sometimes multi-year effort of talking to stakeholders in the area like Harbor Branch and state governments. One of the best examples of collaboration with state government actually was in the Mid-Atlantic area with the Mid-Atlantic Regional Council on the Oceans, MARCO, and helping us cruise plan. So it's a multi-tiered approach. We look at what the academic scientists need. We look at what the federal government research and management agencies need. We talk to state government and see where their priority areas for exploration are. And then at the very end, once we have these kind of large area boxes of specific areas that managers need to know more information about, we reach out to academics like those at Harvard Branch and at University of Louisiana Lafayette like Scott, and get them to help us kind of prosecute those targets to see what's actually there. Scott, you want to talk a little bit more about kind of the detailed level cruise planning?
Yeah, sure. So I've been involved with Brian since at least back in June, talking about the plans for this cruise. There were some initial plans based on workshops that had been done in previous years, expressive interest from the different stakeholder groups that Brian has mentioned. And once we have that information, then essentially I serve as a role to get that information out to academic scientists, to government scientists, and get their feedback so we can begin to refine the plans and figure out what would be the highest priority targets that have the most support from different scientists. And we come up with a draft schedule for where we're going to go. This is before we ever leave the dock. And then that schedule is constantly being worked on as we're at sea, and it has to be flexible. We encounter weather, there are technical delays, and for each step when we're doing that, we are in contact with the various scientists who have expressed an interest in exploring these habitats with us. So, for example, before each night before the dives, we send out a dive plan that explains where we're going based on the conversations that we have had, what the plan is for the dive overall. Brian indicated earlier that we could shift that plan if we get on the bottom and we actually see something surprising that we weren't expecting there. We could shift things, we could get more scientists or a different group of scientists involved, or all the scientists who are involved in that event log who are with us live. Some of them are going to come to the fore as we start to explore one certain feature of it. But we're also flexible in that if the weather or the currents or something causes us to change, then we have conference calls. So after every dive, we have a conference call of the scientists who want to be involved, talking about what will we do tomorrow specifically, and then we also talk about the next day out. We always like to have a couple of days planning here. And so this is always constantly sort of being revised and tweaked, and it can be based on what we observed. We may have had a dive where we saw something really exciting. We want to go back there because there's a push from the scientists that was too important to not take the opportunity to be out there and go and see it again. So there's a lot of input that's important. We are doing exploration, but we're trying to have it be based on some sound science and be able to contribute to future science so that we can come back out here and do the studies that we need to do.
So I know you're planning for a dive this morning. The ROV is actually in the water halfway down to the bottom. Can you tell us a little bit about what's going on right now? And I'm not going to keep you for too much longer because I know you got to get busy and get prepared to get on the bottom and start working on the bottom. Can you just give us a little bit of background about what's going on right now?
Right now we are descending through the water column. I was kind of turning around my shoulder to see if I could see the depth that we're at. Maybe one of the pilots, let's see. We were at 1,720 meters in the water column, so 1.7 kilometers. That's just a touch over a mile deep. We are on our way down to just over 2.5 kilometers deep. We're working on Physalia Seamount. This is an underwater volcano that's essentially poking out of our continental slope. We're only about 200 miles to the southeast of Chatham and Cape Cod, the elbow of Cape Cod. So we're not really far offshore at all, and yet this is the first time anyone will ever have taken a remotely operated vehicle or a sub down onto Physalia. This seamount is of interest because it's within our exclusive economic zone, and we're interested in the resources that are associated with Physalia, and we're interested in using those resources wisely. There's much interest in the management community about the fish and the crustaceans, the crabs and shrimp that may be using this seamount. We want to understand something about the habitat that's available to them. So we've targeted a feature that's on the seamount that has a slope that we think may be of a good shape and slope that it will attract organisms like corals and sponges. And when you have that three-dimensional habitat, you often have other invertebrates and fish that will live in and amongst those colonies. It's a lot like trees in a forest. You have the trees, you have a lot of other organisms that associate with them. So that's what we're going to find out today. We're going to get down to the bottom, and we're going to be able to have several hours to explore what's there, and in collaboration with our scientists, we hope to be having a lot of moments where we're really surprised and excited by what we see.
Well, I'm really excited about today's dive. I'll be following along and participating from the Exploration Command Center here at Harbor Branch. Brian and Scott, I want to thank you so much for taking the time this morning to talk with us and continue good. I hope you'll have good weather. I know you're expecting some weather a little bit later today and maybe towards the end of the week, but I hope it's smooth sailing for you. And we've got a few more days left on this expedition. I guess about a week left on the expedition, and I wish you continued success. And I'll be chatting with you online. And thanks again for taking the time to talk to us today.
Absolutely, Shirley. Thanks a lot, and we look forward to continued participation from the ECC there.
And we'll be keeping our eye out for those sponges, especially the carnivorous sponges. They're exciting to me as well. And you can see that Brian and I are swaying just a little bit. We are in a ship. It is moving. But we're sending you the stable images, so enjoy what you see.
Yeah.
All right, Shirley, anything else from us?
Yeah, I have to tell you that if I were out there, I'd be having a couple of the scopolamine patches on. So this is one of those times. I love going out to sea, but when I look at those, the sea state, it's like, oh gosh, I kind of am glad I'm sitting back here and it's flat calm. But anyway, thanks again, guys, and good luck today.
Not a problem. We'll talk to you later, Shirley. Bye.
Bye-bye.